black one is our loss, and blue one is the accuracy of the conventional denslet, and blue and purple one is the accuracy of the conventional loss of the conventional densnet, right? And we can see that our proposing we are proposing we are providing better accuracy with lower loss compared to the conventional dance. And that's a really impressive claim. So let me introduce you with another problem. For any fundamental of biomedical, if you want to know that I have explained you the pre-processing, I have explained you a structure, and then I have explained you what should be your data, and then what is the evaluation matrix, what is the comparison, how do you compare. Let us see another problem, that is detection of tuberculosis using chest radiographs. For that we have really assembled very novel techniques, like in the lower structure couple of architectures are ensembled together, in the upper structure couple of I should say machine learning hand engineered features are assembled together to get a better voting. You know, these are the handcrafted feature, extracted histogram of oriented gradients, binary pattern of phase, um, and a binary pattern of phase congruency, improved webinar binary code, curvature descriptor histogram, and a shape descriptor histogram, local arc pattern, local transitional pattern, and median binary pattern. You can, if you study the literature, you can get them. The important is how we are proving that they are good features based on geometric separability index and vertex area distance. You can see from the table that hand engineered features are providing lower BD value and lower DSI value. That means it shows better interclass separability and intra-class compactness. This is very, very important. And then we have shown that apart from taking the six machine learning features individually, if we ensemble them, then their values are higher under evaluation metrics like accuracy, area under the curve, sensitivity, and specificity. And we have evaluated them on two publicly available data sets. Now, we wanted to see the effect of architectures. Rather than taking the whole architectures, we have found that which layer gives you the best accuracy, area under the curve, sensitivity, and specificity. And we have evaluated it for inception Vrithi, DenseNet 169, and ResNet 50. And the best layers are shown by bold. And once such features are obtained, we are sending them to classifier. But before going to the classifier, we have prove that with pre-training and with augmentation, the deep learning the deep learning ensembles are giving better matrices for two databases. So once we can prove that we are moving in the better direction, we are sending them to the classifiers. We have evaluated our classification performance using logistic regression, support vector machine, artificial neural network, k nearest neighborhood, and random decision forest, and we can see that logistic regression is performing the better. Now it is time for us to really share and compare our methods with the standard techniques. We can see our proposed method, which is the ensemble of hand engineering ensemble and deep neural network ensemble, are providing the best performance for the two databases we are showing. So this is the grid cam visualization. You can see the normal in first row, tuberculosis in the second row, and you can visually see the differences. And you can see the three different architectures in the second column, third column, and fourth column. But we don't want to depend on this visual observation. That's why we have devised this automatic process to really get the decision very faster and very accurately and help the doctors. Let me tell you the most favorite research of myself, because it has been done in the most difficult condition of my life in 2020, in 2021. The last 2 years has been the most challenging, but I enjoyed the challenge. And because my students were sent back to their village home, and many of them were getting internet connection, climbing up the tree or sitting up the rooftop, and it was a really different story. But I kept on collaborating, calling with them, and inspiring them to collect data from X-ray, CT, and ultrasound images. And they came up with a very good. Oh, by the way, previous tuberculosis work was also published in IEEE Access, but this is the work that has been published in IEEE Transactions on Artificial Intelligence. And they came up with a very good architectures capable of automatically detect COVID-19 from different imaging techniques. Not only that, they were able to detect or handle triggers problem, whether an image is a normal image is coming from pneumonia or image is coming from ultrasound. It was a difficult problem, so they named it as capscovnet. I really love the name. This is the overall proposed method. You can see the ultrasound frames. You have extract the image slices and do some pre-processing like enclashy, and then send it to the developed architecture's capscovnet. In the capscovnet, you can see at the bottom parallel convolutional block rather than serial convolutional block. Then you have seen that concatenation of capsule block instead of a single block, then decoder block before constructing the images. And these are parallel convolutional neural block. You can see different sizes of the blocks. And then the concatenated capsule network block consists of a primary layer and a higher capsule layer, is given by different colors. And then you see the decoder block where it is able to reconstruct the image and able to provide the classification between normal pneumonia and COVID. And these are the results. We have evaluated our performance for three different data sets, and we can show that within Clashy and with pertaining the accuracy, precision, sensitivity, F1 score, specificity, these are the metrics are higher, and that gives us a hope. We have also given a motivation that instead of capsule network with sequential convolutional blocks, the capsule network with parallelly concatenated convolutional blocks provides you the better result. And here comes that we have compared our method with the state of the art techniques. You can see also proposed method is outperforming the other methods for both the setters. And last table is most interesting. We are showing that compared to the conventional methods, proposed method is able to detect COVID, pneumonia, and normal in a better way in terms of sensitivity, specificity, precision, and F1 score. This is another evaluation of ultrasound and X-ray samples. You can see first column normal sample, second column COVID sample, third column pneumonia samples, and the first row original image, second row is the pre-processed image, and third row is the GradCam visualization. And from the GradCam visualization, you can understand what is normal, what is COVID and what is pneumonia. There is some visible differences, but we don't want to. And the first chunk of the first three row is one database, and first last three rows of the chunk are for another database. But we really do not want to depend on this visual observation. That's why we wanted to automate the process to detect with more precision. I always encourage my students. I said 2020 was the toughest year of my life. In 2020 October, a Signal Processing Society has two flagship conferences. One is ICASP, one is ICIP. Both for ICASP and ICIP, there are parallel competitions going on. Okay. And in this 2020 ICIP, there was a competition that is called distortion classification in laparoscopic videos, and for that my students have developed a DisNet network. This is the input image taken from the video. At first, our target is to detect the features for white Gaussian noise, smoky level, uneven illumination, blur level. Once the features are extracted for different distortion, it is sent to classifiers. These are different types of distortion, like white Gaussian noise. This frame is corrupted by noise variance is a key factor. This is the smoky level, and smoky frames tend to have less median value, and these are frames where there is uneven illumination. The ratio of luminance mean to range is a great indicator for this change. And there is blur level also. A blur image will show low variance and less edges. Once such things are defined and we could classify it, we have sent it to the DisNet network. you know and as the for DisNet network, you can see there are sequential convolutional layer. But the why it works so well, before going to the LSTM, which really works for 2D images, we have given a sequential self-attention layer to give a special attention to the distortion presence. And then we have used dense layers, batch normalization before going to the decision. This is the model performance. We are getting better model accuracy and lower loss both in training. You can see the values here, that for accuracy high, loss low, and our statistical score Cohen kappa is very high. And we also exposed ourselves to unseen data. This is another fundamental thing. So we can see, even after exposing ourselves to the unseen data, our accuracy and Cohen kappa score did not decrease much. And finally, this is the results what my students have done. Our method was ranked 3, but our timing was ranked first. This is really very important to give a very fast decision, to know about what are the distortion present, so that mitigation plan can be taken, and the surgery can be performed very well without any chance of fatal death. I have been an advocate of women and children for many years, and we know our women are suffering from skin cancer, and but they feel shy to do it, to check it. These are the different types of digital images containing skin cancer. We are now applying our deep learning techniques to automatically detect this skin cancer. And these are some of my awards, what already I have been introduced with a very humble honor. You can visit my website. It's not about my list of award. It's a list of hard work and commitment. From 2013, it was WA Professional Volunteer Award from Region 10. It is the highest one. 2015 W Inspiring Member Award from Global WA. That is also an highest one from Global WA. 2016 MGA Leadership Award is not about only women. MGA about 160 countries. At that time, it was 336 30 sections among all male and female members. 2019 Regent and Humanitarian Activities Outstanding Volunteer Award, and 2021 IEEE MGA Achievement Award. And who is next? It's you. If I can do it, you can only do it. Only thing is that you do not need to start from the scratch the way I started. You do not need to start from zero or face the challenges that I have faced. So I will be always there to support you if you need any help. And these are the group, Women in Engineering group, for which I was the founder in 2010. My group became the best one in whole region 10 and best one in the whole world due to their different technical activities, conferences, industry activity, entrepreneurship activity, humanitarian activity, society specific activity, and also Women in Engineering BUET student branch, for which I am the faculty advisor, also became the best one in the region 10 and in the best one in the whole world. So if it is possible staying in Bangladesh, many people may think what I can do staying in Bangladesh. It's not the matter whether you are living in Ladakh or live in Kanyakumari. If you have the merit, if you have the passion, you have the capacity, you will do better than me. And this is our two chapters, IEEE EMBS Bangladesh chapter, for which I'm the chapter chair now. And in 2020, I was vice chair. Our chapter became the winner of 2020 IEEE MBS Regional Outstanding Chapter Award. Only two chapter got this opportunity, Bangladesh and Latin America. So in some sense, staying in Bangladesh, working very hard, we all were able to increase or enhance the visibility of Bangladesh, visibility of the subcontinent, and visibility of the whole region 10 to the rest of the world. And also Signal Processing Society, for which I was the founding chapter chair. It's a very young chapter, but in 2021 we got the chapter certification very quickly due to our enormous flagship and impactful event. And I should say that we can change the world as we are engineers, but we have to work together. We can disseminate information to each other. And sometimes what is important that your position can be delayed, your award can be delayed, but what cannot be delayed, your spirit to contribute others, your spirit to contribute beyond borders. So we are doing it, and you are also doing it. Let us work together to support each other so that we can bring good research opportunities for the young generation. And most important, we have to do it as we did not get the opportunity in our younger life. So we have to bring thousands times more opportunities to our young researchers, young students, so that we can fulfill our dream through them. Thank you very much for your patient hearing, and I'm really honored that you are conducting such a meaningful event for your young generation, and I'm really proud of you, and I'm really thankful to you that you have all listened to me. Thank you for your patient hearing. Please let me know how I can help you, and don't think about the border. The knowledge has no border. Thank you very much.
Thank you so much, ma'am. Am I audible?
Yeah.
Yeah, yeah. Thank you so much, ma'am. So, I would like to ask participants if they have some questions regarding whatever talk ma'am had delivered. You can write it down in a chat window. Meanwhile, I will ask you, ma'am.
Any question?
Yeah, ma'am. My question is that whatever the research you had done, The data set you had not revealed, like it was the freely available data sets, or it was taken from some hospitals or some private.
Yeah, the data set were all publicly available. It's very important because the most important fundamental thing is for us, we have to compare our result with some standard state of the art techniques. That means those techniques are published in some journals or conferences. In those papers, we have to already also see that which database they have used so that we can get a fair platform. Same thing actually, and from their source, we have found that which data sets are publicly available. So this is a fair chain of command to really compare your results. So if the data sets are not publicly available, you can collect your hospital data. It doesn't matter, but the data collection should be standard. At the same time, the hospital data that you will be collecting, you have to evaluate the performance of other methods also in your hospital data to show that how you are performing compared to that method in that particular hospital data. So there are pros and cons. So this is the safest and the standard way to see the state of the art papers and what database they are using. If they are publicly available, then your life is in a good condition. If they are not publicly available, you have to take help from those authors, whether they will be able to help you to get the data set. It happened many of my cases. The data set, I was determined to compare our work with their work. That means then I have to use their data set, and I was not finding the data set. So I was just desperately writing to them that I will acknowledge your contribution. I will acknowledge your lab. And then I went through some memorandum of understanding to use their data. That's the simple story. Thank you.
Right, ma'am. One more question I'm having. Sometimes when we want to compare our work, so if data set is same, then it is easy to compare. But if in some applications you are not getting the similar data set, then how you can validate? Like, is there any other uh, the
Yeah,
way? Yeah.
then your life is more difficult. You are not getting their data set in any way, but you cannot stop. So you have your own data. So apply your method to your own data and then implement their method in your data. Finish.
Okay. Yeah.
But that's the difficult part because you do not know the different parameters they are using.
Yes.
So
Very
in that
true.
case, in that case you can ping the authors. I get thousands of requests about revealing different parameters of my papers so that the new authors get the help. So I remain straightforward and I share the parameters I am using. That's the easy way because in that way they will cite your paper, right? They will
Yes.
cite your paper if they're honest. So there is no harm in sharing the parameters you are using. Thank you very much.
Right, ma'am. Participants, if any queries, let me know. And
Ma'am, I am
also, yeah.
Ma'am, I am also having one query. As you have mentioned, when you are having your own data, or sometimes when you are clinically associated with some hospital data, so is it necessary when you are publishing your paper that validation from the doctor fraternity you should provide as a statistical analysis? Is it that much important to validate your answer with doctor fraternity, or it would be good as a technical researcher?
Yeah, it's a very good question. It is really important. You know, when you are collecting your data from the
बिना
hospital
सेशन पतलावर
or
जेवायला
your
कारण का मला क्वेश्चन पण
collaborating
काढून
medical
घ्यायचे आहे. हां,
center,
तुम्ही लोक चालू करा, मी
then
जॉईन करेल मग. हां हां,
you
ओके.
have no ground truth. There should be some ground truth, right? In the publicly available data, whether it is biomedical, speech, image, or anything, they have their standard ground truth. But when you are using your hospital data, there is no ground truth. So somebody should create your ground truth, and that somebody should not be you,
Yeah.
because you are proposing a new method and you will compare your method with other methods. So there should be a neutral person who will create the ground truth and the reference and benchmarking for you, and that is the doctor. The
Okay.
many of the cases, the radiologist, they show the, for the breast cancer, the radiologists show the region of
Yeah,
convergence or
conversion.
region of interest
Interest.
in the
Yeah.
breast cancer area. Then you apply your method and find the your own region of interest. Now question is whether your region of interest is
Same
really
as.
accurate with that sketched by the radiologist who who has created the ground truth. Then you can find that dice value, dice overlapping, that your region of interest and their region of interest, how much they overlapped with each other. So this is the way. And we have to always take reference from them. Doctors' collaboration will always give you a benchmark. Otherwise, you will find your own region of interest and nobody knows what is your accuracy, what is your dice percentage. Nobody knows and you cannot report it because you don't have the benchmark.
Yeah.
Thank-
Thank you, ma'am. Yes, participant, any query?
They must have understood everything. And we are shy. We are a shy nation. You know.
Okay, so if there is no further query, I would like to give you a token of love and appreciation, your time and your great. We want to show us gratitude towards you by giving you the e-memento. So I am sharing my screen. Just wait, ma'am. Is it visible?
Yes, ma'am, it is visible.
Okay, so thank you, Celia ma'am, for sharing such a nice discussion. And definitely, the students and the young generation will get some of the topic to work upon this. And whenever we need your help, definitely we will reach to you, and we will use your information and your work to validate our work also.
Thank you very much. It's a great honor and it's a wonderful moment.
Thank you very much, ma'am.
Yeah, thank you, Arpan. Actually, my what I really didn't share this. I don't remember because I didn't talk to Gujarat. I talked with Mita and Dr. Chirag so many times, but my maternal grandfather was a lawyer in Kolkata 60 years back in the British era. So whenever and recently, my father-in-law has the youngest sister who is living in Gujarat, Ahmedabad. So I got new connection. Hi, Dr. Rajesh. How are you? So I got new connection. So I was always searching the home where my grandfather lived 60 years back in the British era when he was the student of when he was a we graduated from University of Calcutta, but there are many states, and I was thinking today that in Gujarat I found my another relative who is from my husband's side, so I have many reasons to remain bonded professionally, technically, and emotionally. That's really very important. And this subcontinent has thousands of potential volunteers, thousands of potential technical experts, but very few leaders. It's really important to inspire each other to be a technical leader. Each one you have the potential, each one you have the